did not hit any object. Setting to suggested position. I'm going to do otherwise overlap hit an object setting only to sweep position. So the other thing we're not doing is, well, we don't actually have to worry about it. I was like, well, what about the rest of the delta t? Well, we haven't actually handled the case where we're actually colliding with something during our sweep, so it's not a problem. Alright, let's read log files. My favorite part of any day of engineering is reading log files. So moving to the left. Our position after the sweep is, so let's just see, we are holding left and we're not moving. So let's take a look. Why is this number garbage? Our overlap did not hit any objects. Oh yeah, we need to grab that current frame. We're printing out all the trash in our memory space. So let's see exactly what this is saying to us. So our wanted velocity is -1000. Our surface normal is still got this niggling bit of 0. Movement direction is -1 in the y. So that is left. Movement distance is 5. We did not strike an object with our sweep, so we should move to the left. Our position after the sweep. So we need to print out our position before the sweep. Impact point for downward sweep is this. So we've already moved off into negative x land, which we shouldn't have. Our suggested position after the sweep is negative. Yeah, you see we've got this -66 here, but then our suggested position after the sweep is at -61 for y. So we like wanted to move to the left, and we did, but then like when we cast down, the impact point is saying -61. So we probably got something busted with where we're doing our downward sweep. So we did not hit anything. Let's go ahead and start off our starting position. Starting position. So there's probably something wrong with our downward sweep at the end. So our new position is here. So we then do a sweep component straight down, and our doesn't this look messed up right here? Like we're setting these every frame. We should be setting these outside of this loop. So we're sweeping down, and we're using our new position. So this is the position after the sweep is where we're sweeping, and we're sweeping it down, and we're sweeping with the component. So closest distance to floor. We are not in that. It's impact point for downward sweep. So Impact point for downward sweep is the impact point here. So our downward sweep is using the wrong position? Oh yeah, if we didn't have log files, we'd just be banging our heads against the wall and not doing a whole hell of a lot, I think. So we are sweeping down, and the problem is our impact point for the downward sweep. Like, our new position has been set properly. Our downward stuff is working, but our impact point could it be that the impact point for our downward sweep is like the impact point is undefined? So what we need to do is our suggested position after the sweep. So what's probably happening here is we are hitting maybe with our right side of our box or something like that, as opposed to hitting with something else. And kind of like if this is our picture and we're running along, we're doing our sweep test, and like it's actually casting a ray from here down, and it's like, oh, we hit right here. And then on other tests, it's actually sweeping like the right corner down and hitting. And it's like, oh, well, the impact point's right here. So what we actually need to do is we need to normalize that impact point. So we need to like say, okay, well, where was the start of the ray that impacted this thing? Because we said like the object was right here, and then we need to actually like take this impact point and kind of normalize it into the object space, so that, you know, we're not moving ourselves left or right. We're basically like, okay, well, if the impact point was right here, that actually means that, you know, the actual impact point we care about is right here. That's where we should be. So that's what we're probably going to need to do. I'm also going to go on break here shortly. It's been 2 hours of streaming, and it's about getting closer to lunchtime for me. So our starting position and I'm betting that impact point is moving us backwards in, yeah, it's moving us in the X direction as well. So movement distance is 5, we did not, our position after the sweep is such, which is looking good. The impact point for the sweep is again -6. Surface normal is again looking okay. Our suggested position after the sweep is again behind our actual position that we want, because we hit the left key. And then we didn't overlap anything, so we're setting to our new suggested position. So yeah, it's definitely that it is most likely that this thing is all sorts of jacked up. So what I want to do here is I want to check if the position of the object matters for, like, if we pass in a position for the impact point here. I mean, sorry, not the impact point, but the position for the sweep here. We want to know if this takes into account anything real. So I'm just going to do like new position, well, F vector test sweep location equals new position, and test sweep location dot. Let's just set the Z to something really big. And I want to know if we're actually respecting this sweep location right here for moving our component. Or if we're just taking the component's location real quick. I guess I could just actually walk into the code and see what it's doing. But what'd be the fun in that? We shouldn't actually like read the code. We should kind of poke around like it's a black box and never read a damn thing. Because we don't want to learn. We just kind of want to write code until it works, right? And our log looks like such. It says our starting position is this like 38, -5 thing. Our velocity is such. Our surface normal is this. Our moving distance. We did not strike anything in our sweep. Our position after the sweep is that. And then we did. Yeah, so it actually did respect the position we passed it. And the ground is too far beneath us, so now we're flying. So good. Our new position is being respected, so that's fine. So it's going to be that we need to take a closer look at these F-hit results. So it's going to be the start location of the trace, probably. The location world space where the moving shape would end up against the impacted object if there was a hit. Oh, maybe we should be using location instead. Maybe that's kind of, they've already calculated this for us. Location world space where the moving object would end if there was a hit, equal to the point of impact for line test. Example, for a sphere trace test, this is the point where the center of the sphere would be located when it touched the other object. For swept movement, this may not be equal to the final location of the shape, since hits are pulled back slightly to prevent precision issues from overlapping another surface. So maybe we should be using this net quantize. Interesting. So it's got 20 bits. This is a historical E format for vector net serialization. So we should probably be using location instead of impact point. So let's just because that would be I mean, we should just be using that everywhere. That's why we're kind of moving slow with the physics and all that stuff, is I don't know Unreal's physics and how it's doing all of its stuff. So if we know all the information and we verified everything is actually what we believe it to be, then we can very quickly be like, something's wrong here. This is the wrong number. Why is this the wrong number? And then we can solve our problems. Oh shit. Oh yeah, okay, so here we go. So we hit play. And then we start moving. And then, oh god, the world's disappeared. What happened? And then we're going to crash inside of Slate, I'm pretty sure. So we'll do that one more time and we'll grab the logs for it. But what's probably happening is we're moving in the X direction off into infinity, and the camera is following us. So, and then we move to the left just a little bit. Alright, our starting position is 35, negative 35. The movement direction is that. So our position after the sweep is negative 41. The impact for downward sweep is at negative 41, 47. That's what we want. Surface normal is such. Our suggested position after the sweep is 39. So the impact point, the location of this is setting us at, it's backwards. I mean, it's not backwards, but it's into the screen. So the question would be why? Why did it put us backwards? That would be the location of the object when it impacted the surface. So we're moving backwards pretty damn quick. I mean, I could just zero out the X and just forget about all this crap, but I'd much rather understand exactly why the impact location X is what it's doing, because we should be casting straight down. And casting straight down, I would expect our position after the sweep, so our location should not change in the X direction because our down direction has a 0 X component to it. Yeah, so down is just a negative Z there. So the closest distance to the floor is 26. 26? Okay, so why are we 26 units off of the ground? So yeah, okay, so we're actually like casting this ray, and our distance is actually our force stick distance. Our X is 53 versus 57, so the impact point here is still moving us backwards, even though the down direction, like our ray cast is going straight down. The location is actually wrong for the X direction. Like, why would the position have changed? So there's something. Well, the question is, what is exactly the location? Because if the location is actually taking into account the offset for the box, then it's possible that we would always have like a 5. 5 in here when we shouldn't. Yeah, the location's changing for some reason. Well, our distance here was 26. Which is close to half the height. It's not half the height though. Look at where the moving shape would end it up against the impacted object if there was a hit equal to the point of impact for line test. Example, sphere trace test. This is where the center of the sphere would be located when it touched the other object. Well, my question is mainly, why, if the impact point is at 132 and our position is at 132, why is the closest distance 26? Because the impact point should be the location of the hit. So like, and if we're casting a ray straight down, and the Z direction is like, you know, the Z magnitude is basically 0. How in the hell do we have a vector that's 26 units in length? And I guess that's because the, perhaps the distance is wrong? So that's going to be the impact point plus the surface normal times, well, let's just set the surface normal. That x is 0. Let's also set the impact point x equals 0. Movement vector direction is 0, so that's fine. So we shouldn't move in the x direction anymore. Except for discover physics state, which is going to make all the surface normal. Let's lock our position. Let's see, our... So here he is moving around, if we lock the X. Nice. We ran into a wall. Fat Sack ran into a wall so hard he broke the he broke the world. Sweep component and the out normal is wait, what is this crap? Invalid normal from convert query impact normal. Non-normalized out result normal from hit conversion. Well, I mean, here we go. Like, our ground-based motion, like, Fat Sack is running up a freaking plane here. And here he is, like, he was able to just traverse that little holy crap piece of stuff, right? So let's go see if he can walk up this slope over here. Oh, and trust me, we are moving. So we're gonna see if we can get up this big ass ramp, and if it's smooth or horribly jerky. And that's what we'd expect. We're clamping to the ground. And these are ever increasing angles. And this is Fat Sack's traveling theme song. And we just keep heading up. Let's keep going. And he's taking those little jumps just fine. That's a little scene there, and he got over it. He's still going. He can make it. And we're doing those sweep tests along the normals. Nothing too insane going on here. And it looks like it's doing what it should. Yeah, real smooth. Like, this is what we'd expect. We have no sliding, so he should always be able to just keep walking. Like, you know, just right over that little bump. No problem. We're not getting Godzilla stuck in the floor or any of that crap either, even though these are, you know, two objects that are colliding with each other. And that's also looking pretty good. Yeah, just yeah, it's real smooth. Like, I expect the character to move kind of like that. Like, he just snaps to it without losing velocity, which is what we want. We don't want him to go absolutely crazy. And we're still able to move up this wall. So the interesting thing is if we're going to be able to stay on the ground. Are we moving? The surface normal is such. We struck ground and are unable to move in our sweep direction. Okay, so at this angle, all of a sudden our math breaks. And why is it breaking? So the movement direction is in the y axis, and then we have negative z. So z is up. So the surface normal motion is to the right with 1, and then it's up just a little bit. So it's not high enough to actually have us move. Is that what's going on? Also, something horrible has happened to our game clock. You can see this number here is a negative number all of a sudden for And Unreal 4 is all of a sudden after frame like yeah, at some point here our stuff just got all sorts of screwed up. Let's see, why can't we move up this slope? We struck ground. The movement direction is the surface normal is it's high in the z-axis, so it's pretty much straight up, and it's to the right. So our surface normal is saying our surface normal is wrong. Like, that is not our surface normal. It's our surface normal. Like, our surface normal is saying that it's like straight up in the z, and then over to the right. So it's like it's saying our surface normal is it's actually like the surface normal should be rotated to the left 90 degrees. So the surface normal is wrong. Are we printing that out incorrectly, or is that actually just wrong? So that's the surface normal. Have we rotated this? No, we have not. Transform vector, surface normal. Well, let's just put a breakpoint in here. And our surface normal is positive z, very positive, and positive y when it should be. It should be the inverse of this. This is the wrong surface normal. Why is it wrong? So let's take a look at the hit. It's a blocking hit. We didn't start. The time distance is 26. The location is at this location. The impact, the normal is there. The impact normal is the same. Trace start and trace end. Why is the trace... Alright, the trace end is fine. Penetration depth is 0. We're on floor 62. And our component is a static mesh component. I mean, if this is just going to give us the wrong frickin' math, then what the hell are we supposed to do about it? Alright, well, let's stop this real quick. Let's boot it back up and go take a look at floor 62 and see if there's anything odd going on with that floor tile. Because the normal is not right, is it? Like, it's... I would expect negative y, because it's supposed to be going up and to the left. And, you know, like a small... Like, the z should be smaller than the y at that point. So floor 62. That was our floor. Its rotation is negative 70. I don't see anything particularly interesting about that. Let's take a look if there's just anything online with Unreal 4 normal is wrong with sweep. Well, maybe we can actually like turn on the raycast. Turn on raycast Unreal 4. Alright, so I can set trace tags on these things, and then I could like see what the tracing is. Alright. Can we see normals just on an object? It's like I'm trying to view normals, Google view normals, and everything is like show normal is just garbage. Wow, all these nothing on Google on how to like view the normal to a surface. Like normally it's something you can just turn on, like just view this crap. Well, maybe we can do the trace tagging stuff and see something that way. So why don't we just do that? Supposedly it's then the query collision parameters. And it's going to be trace tag. This is going to be physics trace tag. let's see, this is going to be text. We're just going to call it dash. All the things need trace tags. Component query params probably have all the same things. Yeah, the other question would be like, why did the surface normals get all screwed up for the box when we were just running into it, walking left? And I would guess it's probably the same thing. There's something messed up with something somewhere. And it has to do with the angle. The angle at which we're colliding, or something like that. Still not sure why the hell our distance is 26 when we're placing ourselves onto the location each frame. I think our distance would be 0 or very close to 0. There's nothing in my code that's a 26. Oh, let's head off to the left. We'll see if we can walk up those stairs. Except we can't walk up those stairs because there's a wall in the way. Well, we'll just move the wall. And that's another object that we added. So it should be trace tag dash. Oh no. What has happened? So these are all of our ray casts. That's what it's looking like. Let's make them move a little bit faster. Looks like Unreal crashes when you exit if there's a whole bunch of those things. Alright, well, we should increase our speed. One velocity, let's give ourselves 3 times as fast. And I am gonna go on break here shortly. I just don't want to stop in the middle of something. What was that? Just trace tag? Alright, super fast. Now. Let's also get our output log rolling along here. Wait a minute. Alright, there we are. So it's the same thing there. So what's our normal here? Our surface normal is negative in the y direction, right? That's correct. And then slightly positive in the z. So we would totally expect our surface normal to be negative. But then all of a sudden, we get here, our surface normal is still negative, and then bam, surface normal not negative. Surface normal is -9, -9, -9, and then boom, it is wrong. Okay, so also the thing here that's interesting is we're halfway up the object. Like if you see these floors, we're halfway up. We're halfway up it. So there absolutely has to be something here where basically what's going on is something is giving us the wrong normal, and I think it might be like there's got to be an edge case, and maybe we should be casting instead of straight down for our surface normal. Maybe we should be casting, like you can see all of our ray casts are going straight down. Maybe to find our surface normal we should be casting towards our previous surface normal. Yeah, happening mid-ramp is just, that means there's something wrong with Unreal. You know, when there's some degenerate case that they're not handling properly. So, it's going to be something like that. Anyway, we're going to come back, and when we do come back, I'm going to try changing how I'm computing the surface normal. And I'm going to basically be grabbing the surface normal from the previous on-ground state, and I'm going to be using that for the initial raycast to find the surface normal. And you'll see all these lines go instead of down. So thanks for sticking around. And I'm going to take a short break, go get some food, and I don't think it'll take an incredibly long amount of time, and I probably will come back and maybe hang out while eating a few things. We'll see. So, later.